Okay, so one of the things I just watched the video that I just recorded, and I wanted to mention a couple of things because I don't want to confuse you too much. So when I was telling you before about the rules, uh, anti, little c, anti, little e. Okay, before when I was telling you about the rules, I said based on certain reactions you have, so you have 1, 2, 3, and 1, 2, 3. And based on these reactions, if you had a positive here, and you went, I'll just give a random example. I was saying to you guys before, the first thing you do is if the D is there, you put the D on the first chromosome. And then you look for capitals, and there's a capital C, so the C goes in this one. And then you look for the other capital, but there isn't one there, so you're not going to use it. It has to be a little e. So little e is going to go here because we know it's down here. Little e here. Then fill in the little c because it came up positive. And then this is where I wanted to tell you. Once you see this, and I told you that the rule was if there was a capital here, a capital letter, either a capital C or a capital E or two capitals, then most favorably the D wants to be a capital with the capitals. So if there's a capital there, then this D form will be in a capital letter. But since there isn't, the most likely is that this is going to be a lowercase d. But when I tell you this is based on the fact that there is, like, the patient's Rh positive. So if the patient was Rh negative, and for example, never mind this phenotype anymore, if the patient was Rh negative, that means that they don't have the D antigen. They would have the little d, or they'd have nothing. And they say they did have a big C here and a little e here. I told you that the rule was if there was a capital letter here, which there is, I'm showing you, then most favorably there was going to be a capital D. And we would put a capital D here. But what if the reaction came up negative over here? What if this patient was Rh negative and there was no D antigen present? This rule no longer applies. You can't throw a capital D there. I wanted to clarify that. So the rule that I told you was on the second set of chromosomes, on chromosome 2, if the C was present, or sorry, no it wasn't. If the E was present, the E would go over here as a capital letter, and then we had a C, doesn't matter. If there was a capital letter here, then most favorably this was going to be a capital D. But if the patient's Rh negative, they don't have the D antigen, so that rule will not apply. Even if there's a capital letter here based on that patient's phenotype, if they're Rh negative and they came up negative with the D and antisera, then this still has to be a lowercase d. So I just wanted to clarify that in case I didn't give you a good explanation, that the only way that this can either be a positive or a negative based on the patient's phenotype with the rest of the Rh. Sometimes it can be positive, or I keep saying positive, I'm sorry. This could be a capital letter or a lowercase letter based on the rest of the Rh phenotype, only if they have the D antigen. If they're Rh positive, can this be variable? If they're Rh negative, they don't even have this gene. They never even inherited the gene. So 100% of the time, if they're Rh negative, that's going to be a little d, and that's going to be a little d on this chromosome. No matter what the other, sorry, that shouldn't be an e. No matter what the other makeup is, if they test as Rh negative, this is an anti-D, anti-sera. If this comes up negative, they are considered Rh negative. They are not Rh positive. So this rule will not apply. This cannot be a variable capital D or lowercase d. If they're Rh negative, the only option is a lowercase d. So I wanted to clarify that. The other thing I wanted to clarify was when I wrote over here, based on a certain phenotype, when these all came up positive, that was one of the examples I had given. The very first example, I said all of the Rh antiseras came up positive, so this patient has all of the antigens. And then I said that it's not, based on this phenotype, it's not that common to to have the big D, the big C, and the big E all in the same chromosome. Remember when I said that? I said this is not a very common phenotype. It actually is a common, inheritance, but not when this is, if this is their phenotype. So I'm trying to explain this in the way that makes sense. I was saying before that this is not a common phenotype or genotype. This is not a common inheritance pattern, but only if this is what the patient's reactions were. If they have all of the Rh antigens, then this is not how it's presented on one chromosome. If they inherited every single one of the Rh alleles, all of the Rh genes, then this is not going to be a common chromosome inheritance. The capital letters are going to be split up if this is what they inherited. But statistically, this actually is a common inheritance. But that would mean that they have to not inherit, some of these other antigens they wouldn't have inherited. The E's common, this one's common actually. But not having little c, for example. So I just wanted to clarify that depending on the inheritance here, this may or may not be a common genetic setup on one chromosome. But statistically, if you looked up to see how many, that's a chromosome here, this is a chromosome here. But statistically, if you actually looked up Caucasians to see if that was if that's what chromosome they inherited, this is actually a common inheritance pattern. I don't know. It's hard to explain in that way. I just didn't want you to think that this is like impossible or like there's only like a 0.5% chance. Like no, it's pretty high that this is going to exist on a chromosome at one time, but not when they're positive for every single one of them. Then you have to split them up to make it more, to make the probability more likely. And then the last thing I wanted to tell you is, I guess I didn't really do an Rh negative example, so I want to give you an Rh example now. So the same kind of deal applies if you're Rh negative, so meaning if you don't have the D antigen, so anti-D, anti-sera tested with the patient's red cells, comes up negative, that means there is no D antigen. They're Rh negative. Okay? And then based on all of these inheritance, and anti-little e. So just random, if they were positive here, negative here, positive here, and positive here. So they're Rh negative. They do not have the D antigen. So how would we set this up based on that? So I still do my three sets on each chromosome. So we have chromosome 1 and chromosome 2. The first rule always tells you if the D's there, put it on the first chromosome. We do not have the D antigen though. So what do we have? The only option is going to be, I'll do it in a different color. The only option that we have is little d. This patient did not inherit the big D antigen. So we can actually fill it in on both sides, little d, little d. They don't have the big D. And then the way it works from here on out is that you're still going to split up your, maybe I'll just do it the other way. They inherited everything but the big D. You're still going to split it up the way that you would if you inherit the big C, like, so you look at it the same way that you did the first time. The first rule said if the D is there, put it on the first chromosome. If it's not there, like in this example, then you have to put the little d and the little d on the first chromosome and the second, because there's just no big D. The second rule says, look at the capital letters for C and E. Is there a capital C and a capital E? Yes. So what was the rule on that? It said split them up. So put the big C here and the big E here. Separate the capitals. That same rule applies. And then you have to fill in the rest of the spots. So we have the little c and the little e. So we'll put the little e here and the little c here. So statistically, the most probable is based on these results, this is going to be their genetic makeup. And then you can keep changing these up. If they didn't inherit, we can do it this way now. If they didn't inherit the E, we'll go through the rules the same way, just like before. Is the big D present? Are they Rh positive? Is the big D present? No, it's not. If it was, it said to put it on the first chromosome, but it's not, so this is easy. We just put the little d. Little d, little d. And then it says, look at the capital letters. Is there a capital C? Yes, there is. So the C likes to, most favorably likes to go on the first chromosome. Is there a big E? No, there's not. So we're not even going to put it on the second chromosome because it's not there. But we do have a little e, so we have to put the little e here. That was an ugly e. Little e and little e. And then there is a little c, so we're going to fill that in there. And you keep working your way through that once again. There's a very, very rare phenotype where you have your Rh negative, but you have the big C and the big E, and you're lacking the little c and the little e. This is a very, very rare phenotype. Because you guys don't know this yet, but we're going to talk about frequency. Having the E antigen, 98%, oh my God, 98%, I'm almost done. 98% of the population have it. So to give this example, it's a very, very rare phenotype, but you follow the same rules. Is the D present? No, it's not. So you put little d here, little d here. Is the big C, are there big C and big E? Yes, there are. So you're going to separate them. And then it's going to say, look at the next two sets. Well, there's no little c and there's no little e. So you can't fill them in there. So this has to be a big E and this has to be a big C. So you just keep filling them in properly. And whatever your antigen testing results, this is antigen testing. This is what we call antigen testing. You use anti-sera with the patient red cells and you see what the results are going to be. So based on these results, you're going to fill in just like before. But the same rules apply. You're going to want to separate your capital letters and then you look at your lowercase letters. If they're not even there, like this example, then you had to fill in every spot with capitals, and that's okay. But if they were there, then you want to separate your capitals. The C goes on the first chromosome, the E goes on the second chromosome, and then fill in the opposite lowercase ones in those spots. So I just wanted to clarify a couple of those things that I didn't explain very well the first time. And look at your sheets, and your sheets that I gave you online, they actually tell you the frequency that we see in North America. So it actually tells you how common certain phenotypes actually are, and statistically how often you'll see that. So just read through those. You'll have to kind of have a good grasp of that and understand it, and then we'll be good.